Greetings. Welcome to Curie Electronics. Today I am presenting you the topic is ammeter and their range extension. So in this lecture or in this presentation we will see how ammeters are connected in a series and how do we increase the range of ammeters. So So we will, before starting with the presentation, we will see a simulation so that we will understand how do we will get a feel of the things what's going to happen in a circuit when you measure the current. Now, this is a simulation of two parallel resistors. See, two resistors are there. This resistor value is 2 ohm. This is a 2 ohm resistor, and this is zero point 0.5 ohm resistor, and we are connected to ammeters. How we are connected these ammeters? If you see, these ammeters are connected in series. Okay, so these ammeters are connected. So ammeters are always connected in series. Whenever we want to measure current, we have to connect the meter in series. So that means the ammeters are always connected in series. Now we are using a voltmeter to measure the voltage across this 2 ohm resistor and the zero point 0.5 ohm resistor. So this is 2 ohm resistor. So you can see here, this is a 2 ohm resistor and this is a zero point 0.5 ohm resistor. And this is our battery. That's a 10-volt battery. It can supply in simulation infinite amount of current. Now when I close the circuit, what happens? Now current is flowing, and what is the current flowing through this 2 ohm resistor? We have 2 ohm resistor and this is a 2 ohm resistor, right? Here 0.5 amp, no, not 5 amps current is flowing through the resistor. And what is the current flowing through 0.5 ohm resistor? That is nearly that is 20 amps current is flowing through the 0.5 ohm resistor. So one thing we had understood, when the resistor value is low, more current is flowing. See, 20 amps of current is flowing through 0.5 amps and 5 amps of current is flowing through 2 ohms resistor. Now we will see what is the voltage across. Now we will measure the voltage across. What is this? This 2 ohm resistor and 5 ohm current. What we are getting? We are getting 10 volt. That means we will apply the Ohm's law. If you apply 2 into 2 multiplied by 5 amps, what will it be? Voltage equal to IR, current multiplied by resistance. So I is 5 amps and R equal to, what is R value? 2 ohms. The 2 ohm resistor. Now, so we will get 10 volt. But this is a parallel branch. Parallel branch, what we know? Property of parallel branch. Across the parallel branch, voltage remains same. So we will check it here whether it is remaining same. Yes, exactly 10 volt. 10 volt we are getting. Now, this is, see, 20 amps of current is flowing through this 0.5 ohm resistor. 20 amps of current is flowing through this 0.5 ohm resistor. If you multiply 20 multiplied by 0.5, again we are getting 10 volt. So that this is what we should know before we go into the what ammeters and their extension, current, how to increase the current range. Okay, let me break the stop. Okay, now we'll get into the actual topic. What it is? It is ammeter and their range extension. Already we saw how ammeters are connected. Ammeters are connected always in series for the circuit. So after learning the ammeters and their range extension, we are going to solve this question. So first we will learn the what is that? How to increase the range of a ammeter. Okay. Okay, let me come to the next page. Okay, now ammeter we saw it's always connected in series. Now let me draw a circuit. We have a load. This is a load. Let's take it as load. Here we have a battery here. Let it be battery. Then we have a switch here. We have a switch. The switch, this is a voltage potential V. Then I am measuring this current flowing through this circuit using the ammeter. Now the ammeter, all ammeters will have one resistance that is called meter resistance. Meter resistance. Meter resistance. This is given. I'll represent it by Rm, that is the meter resistance, and the current flowing through meter, that is represented by Im, current through meter, that is what Im. Now I'll just mention it here. This is the Rm is the meter resistance, and Im is the current flowing through this. Now if I want to increase the range of this ammeter, what I will do, I will use a shunt resistor so that the current will get divided. I will use a shunt resistor. This resistor, this is what resistor? Shunt resistor. I am going to use a shunt resistor. That is resistor connected in parallel. Shunt resistor to our ammeter. Shunt resistor. Shunt resistor is given by RSH, shunt resistor. The current that is flowing through the shunt resistor. Let me mark it. This is the RSH, is the shunt resistor. And this the current flowing through this shunt resistor is ISH. Now in a series circuit we know the current is same. So once we close, if the current I is flowing through this, after dividing through these two branches, again the same current will sum up here, that is add up. The total current remains same. Now see in this circuit, I will write the equation. Now, normally what we have to find out to increase the range of a ammeter to suit our requirement, what value of resistance we have to add to the circuit. That's what we have to learn. We have to find normally. So now what we will do, I know, and I can write two equations. I equal to I meter plus I shunt. With the current flowing through ammeter. Ammeter will have a winding, one small resistance coil, and similarly the shunt resistance having a resistance. Im is the ISH is the current flowing through that resistance. Now in the simulation we have measured the voltage across both the parallel components. So what was the property, what was the peculiarity there? There, as per the parallel circuit property, the voltage should remain in same in a parallel circuit. So that same property I am going to make use of and write. I will use the basic Ohm's law and write one equation here. Now what I can write, RSHS, I will first write meter resistance. Already you have seen in the simulation what is exactly happening. Meter resistance multiplied by meter current, right, which is equal to what we have measured. This also we checked in the simulation. That's what, once we get the simulation, this is very simple. So this is meter resistance into meter current will be equal to what? That is the voltage across the meter. That will be equal to shunt resistance. That is shunt resistance multiplied by shunt current. That's it. This all we have to know about. Now we'll write with the, we'll make it short. We always like smart, short and small. So meter resistance is given by Rm. What is the meter current? That is Im, which will be equal to shunt resistance Rsh multiplied by what? Shunt current Ish. Once you know this equation, we can find the, or we can extend the range of a, by after knowing this equation you will easily extend the range of a ammeter. Now to understand this, we will solve our one question, one example problem was there, that we will solve it. Now, so we know what we know, ammeters are always connected in series, voltmeters are always connected in parallel, and we know Rm, current flowing through meter multiplied by the current meter resistance equal to current flowing through the shunt resistance we added multiply the value of the shunt resistance. So now after knowing this, we are going to solve this simple problem. Let's see what is the problem. A 100 micro ammeter meter movement with an internal resistance 800 ohm is used in a 0 to 100 milliamps ammeter. Find the value of required shunt resistance. Our actual ammeter. Now I will draw it. So this is already we have learned it. So it's very simple. So what you are going to do? I will draw the ammeter. This is our actual ammeter. That ammeter is having what? This part of the circuit not required for us. What is the ammeter? That is a 100 micro. So Rm he has given. What is the meter resistance? Meter resistance equal to 800 ohm. What is the value of current flowing through this? That is Im. Im equals to what? Im equal to what? Im equal to, he has given in the question, 100 microamps. All of us are very good in converting microamps to amps. Okay, now we are going to add a shunt resistance to it. We are going to add a shunt resistance. That's how we are going to increase the range to 100 milliamps. This is our shunt resistance. So we have to current he has given. What is the current supposed to flow through this? Ish equal to what he has given? 100 milliamps. So RSH we have to find. That is the question. Now we will solve it. Okay guys, so already from the simulation and basic presentation you have learned what to do. Current flowing through is a parallel circuit. So here whatever current flows, that same current should come out. So this is a parallel circuit. Now I will write current flowing through meter multiplied by meter resistance equal to current flowing through shunt, that is Ish multiplied by shunt value. From this we can easily find the RSH. RS shunt Im multiplied by Rm upon Ish. So this will give the shunt resistance. So mathematics genius, all of you try to find the answer. What is Im? Im he has given us 100 microamps. So I'll write it as 100 into 10 to the power minus 6 multiplied by what is Rm? 800. What is Ish? 100 milliamps minus 3. So we will get here 10 to the power minus 3. 100 cancels. Now what is left? We have left with 800 multiplied by 10 to the power minus 3. So what it comes? It comes to This means what? 800 divided by 1000, which equal to 0.8 ohm. So after learning the simulation and understanding how to increase the range of a ammeter, we have solved the problem quickly and easily. So 0.8 ohm is the answer. So guys, I hope you understood. Thanks for watching. Please subscribe this channel and share with your friends. So after seeing the simulation, the current range extension is very simple and ammeters are always connected in series and voltmeters are always connected in parallel. Okay, if I connect the voltmeter in series, it doesn't read anything. Should not do that. Okay guys, thank you guys. See you soon.